Okay, everyone. Subsection 2, Higher Factoring, Part 2, Review of the Factor Theorem. Okay, remember in Math 30-1 we used the factor theorem to factor polynomials with degrees greater than 2. So this is beyond just big X factoring or decomposition, that kind of stuff. So x cubes, x to the fourths. That's as high as we go here, but you can use the same techniques for x to the fifth, sixth, seventh, as high as you want to go. Anyways, remember, the factor theorem states if a polynomial p of x is divided by some factor, x minus b, okay, then the remainder, okay, which is the polynomial evaluated at b, okay, has to equal 0. Okay, if the polynomial evaluated at b does equal 0, then of course the x minus b is a factor of the polynomial. Okay, all very fun and exciting and yay. Alright, so the hardest part of this is being able to determine the possible values of b, or the possible or potential zeros, or the potential factors. Okay, now, if the function has a leading coefficient of 1, okay, then the possible zeros are just the factors of the constant term, okay, both positive and negative. Okay, remember, if the function has a leading coefficient other than 1, so like 2 or 5 or 500,273, okay, then the possible zeros are just the factors of the constant term divided by the factors of the leading coefficient. So let's try some examples and see how this all works. Okay, so for the first one, so we've got x cubed, so the leading coefficient here is 1, so that's kind of nice. Alright, and okay, so the factors, or the possible zeros, are going to be the factors of 15, so that is plus and minus 1, 3, 5, and 15. Okay, and I'm going to admit I totally cheated. I did this beforehand, so I know what the zeros are. Okay, so if we have a quick look at what makes this work, the zeros, or one of the zeros, so let's say p of -1 works. And let me just show you once how this works. So if I put -1 into this equation, so -1 cubed is just -1. -1 cubed plus 9 times -1 squared plus 23 times -1. I'm not going to do this for every single one of these, but we're just going to see it once. So, okay, so that's -1. Then this is plus 9, because -1 squared is positive 1 times 9 is plus 9. Okay, then minus 23 and plus 15. So if we have a quick look at this, okay, -1 plus 9 is plus 8, minus 23, of course that's minus 15 plus 15 equals 0. Okay, so that's why it works, and you can type that into your calculator, figure that out, and it's awesome. So the other ones for this, okay, -3 works, and the other one is -5. Okay, and again, any other combination there, the remainder does not equal 0, so that means it's not a 0. So anyways, if these are the zeros, then of course the factors are x plus 1, x plus 3, and x plus 5. Okay, so that's how we factor these higher polynomials. Alright, so if we look at number 2, and man, I did not leave myself a lot of space here, but that's the way this thing goes. So the possibles here are plus and minus, all the factors of 12. So we've got 1, 2, 3, 4, 6, and 12. Okay, so those are the possibilities. So we start typing those numbers into our calculator, looking, of course, for the zeros. We can also graph these, and we can also use the store feature on our calculator all of those things do work. So when we try these, we find out that the zeros are -3, -2, 1, and +2. So those are our zeros. So then the factors, of course, are x plus 3, x plus 2, x minus 1, and x minus 2. Wow, it's just squeezed that in. Okay, so that's how we factor those. Okay, oops, that's not what I wanted. Okay, so let's scroll this down a little bit. There we go. Alright, so if we look at number 3 now, so now 3 has a leading coefficient. So this is going to be plus or minus all the factors of 15. 15 divided by, well, really, it's plus and minus, but the plus and minus kind of gets taken care of from the top. So plus and minus factors of 3. Alright, so if we have a quick look at that, that's going to be, okay, so plus and minus 1, 3, 5, and 15, all divided by factors of 1 and 3. So, okay, so the factors of 1, that doesn't change anything, so that's just going to be 1, 3, 5, and 15, plus and minus. Okay, dividing by the 3 changes stuff, though, because we have, so 1/3 is extra. Okay, 3 over 3 is just 1. Well, we've already got 1, so it doesn't change anything or make anything different. 5 over 3 is new. Okay, and then 15 divided by 3 is 5, and we've already got him, so we don't have to worry about that. So these are all my possibilities. Having that leading coefficient just gave me the extra 1/3 and the 5/3. Okay, so again, I've done this beforehand, but the zeros, and again, you're just going to type these in and you're looking for a 0. Okay, so -5 works, -3 works, and then 0.3333 or 1/3 works, and that of course is positive. So now the zero, or the factors then, are x plus 5, x plus 3, and then we start this way, x minus 1/3. But remember, we always want integral coefficients here. We don't want the 1/3. So the 3 just multiplies up, so really this just becomes 3x minus 1. So that gives us our factors, and we go from there. Sorry, guys, one thing I didn't mention. You can tell how many zeros you're looking for by the degree of the function. So for this guy, for number 3, I'm looking for 3 zeros. If we have a look at the first one, I was looking for 3 zeros, and there were 3, and there's 3 factors. The second one, I'm looking for 4, and we go from there. Okay, so moving along. Number 4 here, this one's a little trickier, and it's not even trickier, it's just bigger. So we have the factors of 28, so plus and minus 1, 2, 4, 7, 14, and 28, all divided by factors of 15, which are 1, 3, 5, and 15. So really, there's just a lot more choices here, and you'll see, like, there's lots. So okay, so dividing by 1, those are all there. So plus and minus 1, 2, 4, 7, 14, and 28. Okay, and then of course we divide by 3. So 1/3 is new, 2/3 is new, 4/3 is new. Wow, there's going to be a lot. Okay, 7/3 is new. Okay, 14 divided by 3, yeah, that's a new one. Okay, and then 28 divided by 3, yeah, that's certainly new. Okay, The 5s, they're all going to be new. There's not a lot of common factors here. So 1/5, 2/5, and these are all plus and minus, right? So 4/5, 7/5, 14/5, and 28/5. Okay, and then, wow, look at this. So 1/15, 2/15, 4/15, 4/15, 7/15, 14/15, and 28/15. Wow, like that is a lot of numbers to try. Now, again, we can kind of be smart about things. We're going to try all the integers first, but we know we're going to have some of these other numbers, so that's okay. Sorry about that, guys. I'm just making sure I'm recording. Okay, so anyways, what we find very quickly is that -2 works. Okay, so -2 works. So P of -2 equals 0. So yeah, that's awesome. Okay, -1 also works. Okay, now if those ones work, and those are fairly early on in our guessing or our estimating, okay, we can use synthetic division here to really narrow down our choices. Okay, so I'm going to show you how that works, because that is kind of one of those more important skills. So tell you what, I'm going to take this thing, okay, and I'm going to just copy this over. Okay, we'll save that. Okay, go over to the next page, just so I have a little bit more room to show you what's going on here. Clipboard, this guy. Okay, and I've already told you that -2 and -1 worked. Okay, we'll get rid of that. All right, so let me just show you how synthetic division works again, or remind you. Okay, synthetic division, we just put down the coefficients. So 15, 34, -17, -64, and 28. -28, sorry. Okay, we'll kind of do this upside down divide sign. Okay, and then we put the zeros in just as is. Okay, now remember, we kind of guessed and tested and got the -2 and the -1. But let's just carry this out. Remember, the 15 just drops down. -2 times 15 is -30. Okay, so and that just 34 minus 30 is 4. -2 times 4, so 2 times 4, that goes up. So that's -8. So -17 and -8 makes -25. Okay, so -2 times -25 is +50, which is -14. -2 times -14 is +28, which equals our 0. Okay, well that's swell. Okay, so now we just do it again. Okay, and now we put in the -1. So then we bring down the 15. So 15 times -1 is -15. Okay, 4 minus 15 is -11. -1 times -11 is +11. So -25 plus 11 is -14. And -14 times -1 is +14, which makes that a 0. Okay, so the thing is, look, we've got this kind of crazy thing going on. Remember, this is the remainder, this is the constant, that's the x, and that's the x squared. So once we've basically boiled it down to here, what we're left with is 15x squared minus 11x minus 14. Okay, and this we can factor using one of those methods from before, decomposition or big X or diamond method. I'm going to choose to use big X here. And how I do that, okay, so factors of 15, so 1 and 15, 5 and 3. Factors of 14, 1 and 14, 7 and 2. Okay, and I'm looking for factors that subtract to 11. Okay, and if we do that, oh, look at, there it is. So 3 and 7, that makes 21. 5 and 2, that makes 10. They're subtracting to 11. Okay, now what kind of 11 do we want? Negative 11. Okay, so what do the 21 and then 10 have to be to make negative 11? All right, well, that means I got to have a negative 21 and a positive 10. Then we back up the sign, so negative 7 and plus 2. All right, so then we end up with a 5x and a 3x. The 5x distributes to the plus 2, and the 3x distributes to the minus 7. Okay, so those are our remaining two factors. Okay, of course the zeros then would be 7/5, so we can write that up here, 7/5, and negative 2/3. Okay, so that's awesome. Regardless, let's put those other factors in. So x plus 2 and x plus 1. Okay, so there you have a completely factored polynomial. Now remember, we could have done that just figuring out with all our possibles. We would have found them eventually. What did I say they were? 7/5. So 7/5, there's that one, and negative 2/3, we would have found that right here, 2/3. But the thing is, we would have had to test an awful lot of things, so sometimes synthetic division is just pretty handy. Alright, so we'll talk next section. Thanks.